look at this problem in the implicit differentiation section. With this one, we had 5x times the cube root of y plus 5y equals 10. And we were trying to find the derivative and then use that derivative to find the slope at the ordered pair 1, 1. Okay, first step. I went ahead and rewrote my 5x times the cube root of y as 5x y to the 1/3. That's going to make it easier to take the derivative of it. Now, as I take the derivative of this relation, in the first term, I remember it's the product rule. You have the differentiable function 5x times the differentiable function y to the 1/3. Derivative of the first is 5 times the second y to the 1/3 plus 5x times the derivative of the second. Be careful there. 1/3 came down in front times y to the 1 lower power, negative 2/3, times the derivative of the inside, which is dy dx. Now, plus 5 times the derivative of y with respect to x, which is by definition dy dx, equals the derivative of 10, which is just a 0. Now, in this next step, I gathered my dy dx terms. So this term and this term have a dy dx. If I factor that dy dx out, in this first term, I'll have 5 over 3 x times y to the negative 2/3. That's where I got that from. In the second term, when you factor out the dy dx, you're just going to be left with the plus 5. That's where that came from. Now, I went ahead and moved the 5 to the 5y to the 1/3 to the right. Had to become negative when you change the sides. And then in my next step, what I recognized is that this group that I was going to be dividing by when I was solving for dy dx, it had a common factor of 5 that could be pulled out of it. So I went ahead and factored out that 5, and then I divided it into the numerator's factor of 5. And so my fully factored final fantastic form of the answer was just negative y to the 1/3 divided by 1/3 x y to the negative 2/3 plus 1. Now, I like my answer better than the answer that my lab has here. Their answer's the same as mine. It's just they are multiplying the numerator and denominator by 15. It's not factored as well in my opinion. So if you multiplied my answer by an understood 15 over 15, you would get to their answer. They would accept, of course, this answer as well. I think it's superior to theirs. Now, as far as finding the slope of the curve at that point, we can go ahead and say, well, let's evaluate this derivative expression when x is 1 and when y is 1. When you do that, it's not bad at all. You'll just get negative 1 in your numerator. When you plug a 1 in for those terms in the denominator, you're just going to get 1/3 plus 1. So my denominator 1/3 plus 1 gives me 4/3. Negative 1 divided by 4/3. If you divide by a fraction, you multiply by its reciprocal. So we have negative 1 times 3/4, which gives me negative 3/4 for my final answer. And that matches what they would have, of course. All right, guys. Hopefully that helps you out with this one.